Hello everyone, welcome back to mahasarkar.co.in. In today's video, we are going to start new lesson number 5, that is oscillation. This will be most important lesson for CET exams point of view. So let's start the lesson. Already you may have familiar about the concept of oscillation. What are called as oscillation? Then I will say in very simple words. What are the oscillation? So suppose simple pendulum is there. So simple pendulum is suppose suspended from the mean position. So suppose this is the mean position and from rigid support. It is suspended from what? Rigid support. Okay. Now if I pull it, say suppose it moves up to certain point and displaced by certain value, again come back to mean position and again displaced to the another position. So it is completely performing to and fro motion. It is completely performing what? To and fro motion, but that to and fro motion is repeated again and again. So when any object is performing same set of motion again and again, then that same set of motions is called as what? Oscillation. So what is the oscillations? The repeating motion performed by object again and again, or when object, or I can say when same type of motion is performed by particle, performed by object again and again, is called as what? The oscillation. One complete set of such motion, is called oscillation. Single oscillation. Oscillation also you can read it. Okay. Now, when I consider that time required to complete one set of oscillation or one oscillation is called period of oscillation. Okay, these are few basic definitions that already we are well familiar with it. Now, remember this oscillation is always to and fro motion along same path. To and fro motion what? Along same path. Because of this, the special type of the motion which we can describe here, that is an oscillation, then when we consider that same type of motion is described by the particle again and again, then that motion is called as what? Oscillation. So exactly here, this oscillatory motion is described with the help of one important type called as linear simple harmonic motion. So one thing is clear, that it is linear motion. Then what is simple harmonic motion? To understand this, let's consider one basic example. Suppose there is a spring suspended from rigid support. Okay. And this spring is connected to one pan in which some load can be added. So before connecting to the pan, say this is the mean position of the spring. This is which position? Mean position of the spring. Now suppose because of the load, what is happened there? What is going to happen? Because of the load, now spring will get pulled downward. So the structure will appear like that. Say it is pulled up to this value. So this is the mean position and this is the maximum position which we can say. So up to this position, say it is displaced by x. Okay. But now it will not stop there. Why not stop there? Now I would say here, why that pendulum was suppose shifted this side, but why it is coming back to the mean position? Then I will say one important factor which is acting there. That factor we called restoring force. That factor is called as what? Restoring force. Okay. This restoring force will try to bring that spring to the mean position, this original position. But again, the spring which was initially at rest, its potential energy is converted into kinetic energy, and because of that inertia, the spring will not stop, and then it will find it is compressed nature of the spring here up to this distance. This distance will also what? X. So what has happened? Spring at rest, pulled, get expanded, again get compressed. It is expanded by value x and compressed by also value x. This expansion and compression will keep on going until the forces get balanced. This force, restoring force, and the load connected to the spring will get balanced. So what has happened here? See, object is displaced away from the mean position. Here also, this is the mean position. Okay. Here also it is displaced away from the mean position. So from here also restoring force is trying to pull it to the mean position. Here also restoring force is trying to pull it towards which position? Mean position. So such type of motion in which restoring force is trying to pull the object towards the mean position. Okay, that type of motion is called as linear simple harmonic motion. So it is, remember, compulsory, it is a periodic motion. It is what? Periodic motion in which the restoring force acts towards mean position. Restoring force always acts towards what? Mean position. Now, more is the value of displacement, more the force will try to pull it up, and its magnitude is directly proportional to displacement of the particle in opposite direction. Therefore, the periodic motion in which restoring force is always acts towards the mean position and magnitude directly proportional to the displacement in opposite direction, this type of motion is called as linear simple harmonic motion. You can write in short linear SHM. So if I write this mathematically, then if F is restoring force, X is the displacement, then how can I write mathematically? Then I will say F directly proportional to X but minus sign. Why minus sign? As I said already, they are opposite. Restoring force is trying to pull up and displacement is in opposite direction. Okay, therefore F equal to minus K into X, where K is a constant of proportionality, and here it is called as a force constant. It is called as what? Force constant. So from the equation 1, say what is force constant is equals to in magnitude minus F upon X. So it is F upon X in general. SI unit is equals to Newton per meter. Dimensions are equal to force upon, so force as M1 L1 T minus 2, but divided because of this L, it will be L0. So dimensions will be what? M1 L0 T minus 2. Another formula, if I write the value of force in terms of mass into acceleration, then acceleration per unit displacement A upon X is always omega square, that we are going to prove. We can have another value of K, that is equals to M into omega square, where omega is called angular frequency. Omega is called as what? Angular frequency. Okay. I hope you understood today's article. Linear simple harmonic motion is the base of this entire lesson. So what is linear simple harmonic motion in short? Periodic motion. It is periodic motion in which restoring force is always towards the mean position, and the displacement of the particle takes place against the mean position. Such type of motion is called as what? Linear simple harmonic motion. In linear simple harmonic motion, F is always equals to minus K into X, where K is M omega square or F upon X. I hope you understood today's article. Thanks for watching mahasarkar.co.in. Have a nice day.